another way of getting the data back again. MRO will replay what it heard back to Earth, and that replay will start. That replay will happen several hours after landing, and the data will actually be available to us. We have to go through a slate decoding process once we get that data down, but we'll have that about 10 hours after landing. And I have to say that I'm extremely excited to be watching all of this through whatever data we get on the screens here, and I can't wait for all of us to see it happen tomorrow night. And with that, I'll turn it over to Richard, who will walk you through what's happening after touchdown.
Okay. Well, good morning, everybody. I'm Richard Cook. I'm the Deputy Project Manager. I like the tractor beams in the video. That was cool. So I'm actually going to talk about what occurs after landing. And, of course, you know, the big difference between cruise, as we are right now, and once we land, is that our ability to communicate with the vehicle and to see what it's doing all the time changes. We can do that during cruise because we have, at this point, continuous deep space network tracking, but once we're on the surface, it changes pretty dramatically. Part of that's because, to be honest, we don't know exactly. Well, Steve told you what the plan is for landing, for communications. Clearly, there are situations that will occur or potentially may occur during EDL where we won't be able to get that communications all the way down. Some of them we know about when the vehicle separates. For example, the rover separates from the descent stage. But in addition, there certainly are situations that might come up where we will not get communications all the way through. And it doesn't necessarily mean that something bad has happened. It just means that we'll have to wait and hear from the vehicle later when it gets opportunities to communicate with us in the subsequent day or hours and days following that. So what I'm going to talk to you about first is really those communications opportunities that occur right after landing and what we expect to see during those opportunities. So if we start with the first slide, and I have to show view graphs because I'm an engineer, I guess, and so here's my view graphs on what we expect to see in terms of communications opportunities on August the 6th, clearly after we land late at night on the 5th. The first opportunity for hearing from the vehicle is the one that Steve referred to, which is actually during the landing itself. And we do expect Odyssey to remain visible from the rover from anywhere between 2 and 5 minutes after landing. And during that time, we should get some engineering data. We hope to get an indication that the spacecraft transition mode into what we call the surface mode, out of EDL into surface mode. And it's possible we also might get some images as well, and I'll come back and talk to you about that in a second. But because of the geometry that Odyssey is in, as you saw from the video where it flies over kind of off to one side of the rover, it turns out we actually have a separate Odyssey opportunity later, about 2 hours later that night. And so it's at 12:30 in the morning is when we expect to get that second pass. It'll again be about a 9 or 10 minute overflight. And hopefully by that point we are essentially done with all of the first set of activities we wanted to do on the first day of after landing. It's we land basically at about 3 o'clock, 3:30 on Mars, and so this rover has another hour, an hour and a half of activity to do, and then the Odyssey overflight will occur, and we'll basically be done with the things we expect to do. That Odyssey overflight will be the next opportunity to get some pictures back, and again, I'll talk a little bit more about this in a bit. But we are in both of these 2 overflights that late morning or late evening, rather early morning. We expect that we might get some black and white fisheye lens HazCam images, and I do have the rover here in case you guys are wondering what cameras we're going to be taking pictures of. They're from the HazCams that are on the back of the vehicle here, and they are black and white. We might get they have covers on them, and so we might actually get images from the first pass and right after landing through those covers. The covers are actually transparent, but then we'll actually deploy those covers and we'll take some more pictures, and so we may see those images in the second Odyssey pass that occurs late at night. Then basically the way that the Mars and the orbiters work is that the spacecraft or the rover is sitting on the surface, and the orbiters continue to go around, but they're not lined up with where the vehicle is, and so we have to wait 12 hours essentially for Mars to rotate under the vehicle, under the orbiters, and then we'll get our next opportunity to communicate. And because we have 2 orbiters, we get two almost at exactly the same time the next morning here on Earth, 11:30 in the morning, 11:40 in the morning for Odyssey and for MRO. And so again, that would be the next time where we would hope to hear from the vehicle. And again, depending on what has happened during EDL, as well as what happened in those first few minutes after landing, this could be, in fact, the first time we hear from it, depending on what has occurred. So those are the overflights from the orbiters. In addition, we have the ability with the rover using its high gain antenna, you see here, to communicate, and its low gain antenna to communicate, which is right here, to communicate with the Earth directly to the Deep Space Network. And so because that's a very much farther distance, the vehicle's transmitter is not that strong, we don't actually expect to get data from that communication path, but what we do is what we call a beep, which is a little bit like a tone during EDL, where the vehicle essentially just transmits a signal and through the low gain antenna, and it tells us that it's there and that it's running the sequence that we expected it to see. And so that will be the first time that we get a direct communication without going through the orbiters, and it'll occur depending on what path we're on, somewhere in the 5 to 6 p.m. The following night, next Monday night. So that would be our first direct path. Assuming that we do hear from the vehicle, we then transition into what I would call normal surface operations. And the big difference between normal surface operations and what we're doing now, again, is really the uncertainty. There's just lots of things that are different about this vehicle on the surface. It has different power configuration. It has the environment that it's in we don't know anything about. So there is a lot of uncertainty into how quickly we'll be able to do things. But if we go to the next chart, I wanted to give you some idea of kind of what the plan is. And you'll hear lots more about all this each day as we go along from Mike Watkins and Jennifer Trosper, the mission managers, as to what the plan is each day. But I kind of wanted to give you the big picture view of what we're going to try to accomplish as we get through the first few days. So the first day, as I said, after we land, is really just to get the vehicle stable on the surface. And it's also then to get prepared to deploy the high gain antenna. We do communicate with the high gain antenna, but it requires knowing where the vehicle is in order to point the high gain very precisely at the Earth. And so the first thing we need to do is to deploy it, and then to figure out essentially where to point it so that we can communicate directly from the Earth, to the Earth, and as well as send commands through the high gain antenna. The next day, we would then deploy the mast, the RSM, and that will give us the ability to take pictures with some of the cameras that aren't accessible otherwise. So that's why, for example, our first pictures are the HazCams, but after a couple of days, we should be able to take, NavCam images and begin to do MASTCAM images as well. On the third day, we will do a checkout of all the instruments just to make sure that they're all still functioning, sort of a very simple aliveness test for the instruments. And as I mentioned, will be our first chance to take a panorama we'll have gotten these little postcards of the area in front of the rover, but this will give us a chance to get our first 360 panorama. Then on the fourth day, we basically have a quiet day. The panorama is a big set of pictures, takes up a lot of data volume, and so we want to essentially not do a lot else other than just send that data down and have it on the ground so that we can begin to plan what to do long term with the mission. Once we get past that, then we transition to an important engineering activity that will take several more days, which is that we have a set of flight software which we've used during cruise and the landing event, but it doesn't have all of the functionality that we want to use for the surface. And so we want to transition flight software versions, basically. The flight software version that we're transitioning to is already on the spacecraft. It's already been loaded up there, but it's not running. It's not active. And so it will take us several days, actually, to transition over to it and begin to use it. If we go to the next chart then. This I kind of talked about already, but just to talk a little more about the products we expect to see as we go through this. And there have been various press releases already talking about this at some level, but just to reiterate, the main idea for the first night is to get these black and white low resolution HazCam images. And again, we expect to get thumbnails, which are very low resolution, like the 50-bit or 50 pixel by 50 pixel kind of little thumbnail postcards. And then we hope to get that first night a more like 512 by 512 pixel kind of image, again, black and white, looking out the rear of the rover. After we get through that first day, then we'll start to send down the MARDI images that Mike Malin talked about a couple days ago. This is the descent imager. We'll start sending down the thumbnails of that. So selected images as we were going down through the landing event, we'll take those pictures and send them down. The first color picture, we're actually using the MOLLE camera that's on the end of the mast. And we're actually sort of looking out sideways out the rover, and we'll take our first color image using it and send it down on the third day or so. And then, as I mentioned, we'll eventually get to doing the NavCam panorama, and that will take several more days to get. That's when it will start coming down on the 9th, and it will take several more days to come down. And again, this is the nominal plan. Clearly, if the vehicle is experiencing issues, or if we have other, we're trying to work through, problems, that we'll have to change this plan in response to that. Once we get beyond the first few days, then I just laid out a little bit of what's the long-term plan for the first couple of months, first 2 or 3 months. And again, I think Pete probably mentioned it the other day when he was talking, Pete Tysinger, but this is a very complicated vehicle. It's way more complicated than MER or other vehicles we've flown in the past, and so it's going to take us a while to first check it out and then to get into the science that John Gratzinger and Ashwin and everybody else wants to do. This is sort of our nominal plan. Again, it's going to be responsive to what we find. We're going to spend almost the entire month of August really checking out the vehicle, getting the first images. We will obviously be getting science data during that, but we'll also be doing engineering checkouts of the instruments, of the sampling system, changing flight software, doing other things. Hopefully by early September, we'll be at the point where we can do our first drive and have the vehicle begin to move around a little bit. And then beyond that, we'll go into the sampling where we first do a scoop sample in late September probably, and then a drill sample sometime after that. October, November is what we're expecting at this point. So I think that's my last thing on the planned activities. Let's just go to the next chart for a second. Quickly, but to finish up, one thing that people are always confused about, and so this is our effort to try to explain it a little bit, is the difference between Mars time and Earth time. I tried to give you calendar days on the previous chart to sort of tell you when we expect to get things, but obviously in reality the rover and all of the operations team, all 700 people if you count the scientists, are all working on Mars time, where the vehicle to be synced up with what the vehicle is doing. A Mars day is about 40 minutes, 37 minutes longer than an Earth day, and so in fact the relative clocks or days shift over time. We land on Sol 0. And it more or less corresponds, as I said, to about 3 o'clock when we land is like 3 p.m. on Mars, and then that every day basically the relative correspondence between the Earth day and the Mars day will shift by 40 minutes. And so you can see we'll be Sol 1, August the 6th primarily, Sol 2, August the 7th. Eventually they'll drift to the point where we will instead of having to have people here in the middle of the night to watch the rover, it'll be during the day, and that will be okay for a couple of weeks, and then it will shift back again. And so you can imagine that it's like losing a time zone every day. Gets pretty tiring, but it'll be exciting because we'll be operating this vehicle on the surface, and so I think that will get us all inspired to work on Mars time for at least 90 days is the current plan. So with that, I think I've spent my time, and I will turn over to Ashwin to tell you about the weather.
All right. We always make you wait to the end for the weather report, just like if you remember from a couple days ago, I'll just go over why we care about the weather on Mars. There's 2 things that determine the accuracy at which we land. Basically, the size of that ellipse that we're placing in that flat area next to Gale Crater. One of them is how accurately we enter the Mars atmosphere at the top of the atmosphere. And as you heard from Arthur, we're coming in really nicely down the middle. So now the next thing that could affect the accuracy of the landing is how well we've been able to predict the conditions at Mars in the past few years based on data from previous missions that we then use to simulate the EDL, the entry, descent, and landing into the atmosphere. We continue to monitor that. We've designed the spacecraft to basically handle all the conditions that we've seen in past years, whether they're clear or dusty, but we continue to monitor it in real time, getting data from the orbiters at Mars every day this week to make sure we understand what conditions the spacecraft will encounter as it's flying through the atmosphere and just how accurately we can expect to land. So I left you 2 days ago with a bit of a cliffhanger. We had seen a local dust storm south of Gale Crater. This had the possibility of evolving in a few different ways. One thing, it could have drifted towards the landing site. That would have been